surveys. If you've not watched that video, sorry, how am I supposed to respond to this stuff that always pops up? Is it got it? Because whenever I click on got it, it ends the meeting for me. You know what? I'll just put it in one corner.
Good.
So please, if you've not watched the video, you should definitely watch it, because that will give you I think in fact 2 videos past, we posted a video on sample size calculation for simple random surveys, as well as sample size calculation for complex surveys that involve stratification and clustering. You really need to watch those videos to have a very firm grasp of everything about survey sampling, right? So if you haven't, the video is on our LinkedIn page. Lungi, that's correct, right? I believe
yes, that's correct.
Okay, great. So please, if you haven't, you should go to our LinkedIn page and watch those videos. That would give you a very solid grasp. And they aren't very long videos, about 5 minutes long or so each. So that will give you a solid grasp of sampling. So today we're going to cover definitions and concepts, simple random sampling, and systematic sampling. And then next week we'll cover the rest, including stratified sampling, cluster sampling, and then sources of error in survey design. So let's talk about some, again, we've talked about some of these slides, so I'm just going to go over some things very fast, because some of these things are things we've spoken over and over and over. All right, so, sorry, let me see. Are there new people who are attending this class for the first time? So I know not to rush over some concept. If this is your first time, can you just raise your hand up? Great, we don't have any new people, so I can go over some of these things really fast. Oh, okay.
Oh, we do have someone new.
Oh man, all right, God's time, Moses, all right.
Oh, Christopher, second time, okay.
Okay, all righty. I'll give it some time over each slide then. Let me go back to the previous slide. So survey design is a science, but it's also an art. In fact, I think it's more of an art than even a science. It's not 50-50. So that means that if you asked 10 survey statisticians to draw up a plan for designing a national survey, you might probably get like 20 different designs, and all of them will be valid, right? That just attests to the fact that there's an art to it there, where you have personal preferences and, and just style, right? And so there's that flair there. So your job is to discover your own flair and your own style of doing things, because like I said, there's a lot about personal judgment. And so that's why it's one of those things where it's hard to say, it's not black and white. Many things in design of surveys, it's not black and white. And because there's this component here that has to do with the art of survey design. And then there's also the science. So you can't just do whatever you want, So the artistic license, as you have it in other fields of creativity, doesn't apply here so much, because sure, you have the art aspect, but then you must operate within the boundaries of the science, right? You can't invent science. There are rules of science. And so we're talking about some of those rules today as relates to probability. And then you need to be familiar with the target population very well. You can't design the survey for a place where you have never been, right? It's kind of abstract. At least you have been there virtually, at least. You need to drive through the area. Like if you're going to do a survey of a state, let's say you live in Jigawa State, and you want to do a state representative survey, you got to drive through the state, go around, see how the areas are located, see where people are. Are there homeless populations? Do you have to account for them? How are structures built, right? How do people live together? You need to have a solid understanding of the target population before you design the survey, because remember that your survey is supposed to yield inferences that will be generalizable to that population. So there is a need for familiarity with that target population. So you got to go around, you got to get some maps and look at those maps and say, okay, wow, this is the area, this is how it's broken up. So it's not a purely academic exercise. There's an applied part where you have to really steep yourself into the population to understand it very well. So 3 things you have to worry about when designing a survey. Now, this is a pop quiz for you. you're brought into a a company or a country, Ministry of Health calls you and says, "Oh, we want you to design a." Please, can you kindly mute yourselves, please? Let me see who the culprit is. Okay. So somebody brings the Ministry of Health of a country brings you in and says, we want to design, we need to design a national survey for us. What's the first question you should ask them? Who knows? Like what's the first question you should ask? So you are a survey epidemiologist, survey statistician, or an expert. You're brought in to design a national survey, or somebody brings you to design a very large survey. What's the first question you should logically ask? No idea.
Maybe the target.
Trust me, it's not a trick question. Objective, sure. Sure, you could ask the objective. But what else could you ask among the top questions?
The
Type of the
population.
survey.
Population,
Target
okay.
group.
Yusuf, good man. The budget, like how much money you got, okay? Because I can design a survey. The survey I'm going to design for you is largely going to be dependent on how much money you have. So before we go into any, you might not even be able to afford the survey, right? So before I go into all of these intricacies and like talk about populations and sampling, I have to know how much money you have. Like what's your budget, right? Because I can design a survey of $10 million for you. I can also design a survey of maybe that's $10,000 for you too, right? And that the variation in between those two budgets there's a whole lot going in there, right? Are we going to go to people's houses? You're right. Are we going to administer via interview administered survey, right? Are we going to use computer assisted telephone interviews? Are we going to use this? All of those things cost money, right? So we got to know the budget. The budget is a huge, huge constraint for how the survey will be designed and how many people are going to include and all of this fine stuff, right? This affects number 2 and affects number 1. Because if you have a small budget, well, literally that affects the number of people we can pull into the survey. People, please can you kindly mute yourself? Let's see who this culprit is. Okay. So your budget affects the number of people you can enroll, which affects obviously precision, because remember the number of people drives the precision. And the budget could also even affect the validity, because if you don't have a large budget, you might just say, well, let's just get people around us. Let's do a convenient sample because we don't have a lot of money. So it is very important in the field, practically, especially if you're in the business of research. Yeah, you got to know the budget first. Like, how much money do you have? Like, how much do you want to spend on this stuff, right? Because then that drives a lot of things. So I just wanted to make sure we're all on the same page. That it's not just about the science; it's also about the logistics. So you have to be a good logistic person for you to be a good survey methodologist. So those two things go hand in hand. Costs influence the precision. If you have a small budget, maybe there's just a limit to how many people can recruit, and that just affects precision of the results. We've talked about some of this. The cycle of inference. The cycle of inference essentially says that from a population, we draw the sample, and the sample is used to make inferences back to the population. There are generally 2 types of sampling approaches. There is probability-based sampling and non-probability-based sampling. What determines which sampling approach you should use? I'm looking for one word that starts, oh, the word is already on the slide. Okay, I'm looking for one word that starts with the letter I. The answer is literally on the screen already, but how can I identify that word?
Intent.
Intent, exactly.
Intent.
Generalized knowledge.
Yeah. So your intent determines whether you're going to use a probability sampling approach or a non-probability sampling approach, right? So don't worry about the highfalutin stuff in textbooks or anything. No. The question is, what is your intent? So again, let's drop back. We said when you asked to design a survey, the first thing you should ask is, yo, how much money you got, right? the second question should be, what's your intent? Like, what exactly do you want to use the survey for? So you have to understand the intent for the survey. Is it going to be, so intent could be, oh, we just want to understand how our employees are suffering. So I'm going to give you intent, and then you're going to let me know whether you're going to use a probability-based sampling or a non-probability-based sampling, okay? So let's play that game. So your boss and they say, oh, we just want to know how our employees are doing. Is there an intent to generalize knowledge? Yes or no?
No.
Okay. So what kind of sampling should you use in that case?
Convenience sampling.
Yeah, you can use non-probability based,
sampling.
right?
Yeah.
Someone says, oh, okay, we just want to understand how patients who live with this condition, patients who have this rare disease. Let's say you're studying, let's say Fabry disease, a rare genetic disorder, very, very rare. So this pharmaceutical company says, oh, we just want to understand how patients with this condition are suffering and their unmet needs towards care. What is the intent there? Is there an intent to generalize knowledge? Yes or no?
No.
Yes.
No.
It's a special population.
Okay.
Yes.
Yeah.
Non-probability based sampling.
No. No.
Okay. Now, another thing you also have to worry about is the logistics. How easy is it going for you to recruit that population, right? So we'll talk about the cost. We'll talk about the intent. So some people may have very grandiose intent, right? Oh, like the company might tell you, yeah, we want to generalize knowledge. I want to make sure our study is representative. It's your job as an expert to think and say, okay, how easy will it be for me to recruit these people? Now, if you're talking about a rare disorder, what should be very apparent to you immediately? We're talking about a rare disorder, right? Let's say Fabry, rare genetic disorder. What's the first thing that should come to your mind at that point, as far as recruitment is concerned? Is it going to be easy or is it going to be hard?
No, not easy.
It's not going to be easy, right? So for those kind of rare disorders, right, what do you think is just look at these options here. Which mode of recruitment do you think is the one we most commonly use in the field to recruit people for a condition that is very rare?
Snowball.
Exactly.
Volunteer.
Yes,
Snowball.
yeah, volunteer is great, but then most commonly we use snowball, right? So you might have a bunch of volunteers first, and then you ask them, hey, do you happen to know other people with this condition? Can you forward the survey to them? And they can forward to other people, right? So you also see we've identified 3 things you have to worry about as the person designing the survey. So again, remember, there are 2 sides to this aisle, right? There's the client or the customer who wants the survey done, and there's you there. We're now assuming that you are the expert who is doing the survey. And you have to worry about 3 things. You have to worry about the cost, you have to worry about the intent. The client, what's the client's intent? And then you also have to worry about logistics or the feasibility, right? And then it's your job to advise this client that, well, I know you said that you want a representative survey, but it's going to be almost impossible for us to pull that off. Why? Because of blah, blah, blah. We cannot recruit, we have to do this. So your survey will have to be XYZ, right? That is how you speak as an expert. You use your knowledge of the context to make clients, whether companies or governments, to be aware of what I don't have to wait until after we do the survey to realize that it's going to be impossible for me to recruit. As an expert, I should know that already. That's what expertise means. You don't have to go the whole mile before you know what's going to happen. You know upfront that no, that will not happen. So, so the reality of the world also determines what you do, right? And so, again, if recruitment is going to be hard, we may have to resort to snowball sampling. So again, the litmus test for generalized, for what sampling methods we use is based on whether there's an intent to create generalizable knowledge. All right, let's look at some quick definitions so that we're on the same page when we talk about sampling. Sampling unit. Sampling unit is the list of sampling units from which a sample is drawn. So we have a sampling frame. So the Excel spreadsheet you all were looking at, what do we call that? You all access the Excel spreadsheet, right? for this homework number 4. So what do we call that spreadsheet? Exactly. The spreadsheet is called the sampling frame.
Frame. Yeah.
Right. And so each row in that is called what?
Unit.
Exactly. The
Sampling
unit of sampling, right? So the entire spreadsheet is the sampling frame, and the individual rows are the unit. How do we create a sampling frame? How does the sampling frame come up? Does it like drop from the sky, or do you create it, or do you buy it, or how exactly do we create a sampling frame? Because again, it's your job to create a sampling frame, right? You know, so somebody comes and says, hey, we want to design a national survey for Tanzania. Well, you can't be asking them, hey, can you give me the sampling frames? Like, okay, that is exactly why I hired you. Are you not the expert? So like you have to know all these things, right? And not just know them in theory. You have to know how to do them. So again, my question is, how do you create a frame? To create a frame, what do you have to first do? All right, let's take it this way. Who remembers this frame, this framework we call PICOT? Exactly. Isha, you're absolutely correct, right? What's the P in PICOT? You're very shy this morning, all of you. The P is population, right? So for you to create a sampling frame, you have to know the population, right? And sometimes, you know, so if I want to do a whole survey of let's say my study is let's say students, high school students. One option is I can get a list of all the students who are high school students in, let's say my survey is a survey of kids who are in high school in Nigeria. Let's start from the hardest sampling frame to create to the easiest one to create. The hardest one would be to say, let us create a list of all the students who are in high school across all of Nigeria. Now, what challenges could I easily run into with that approach?
Lack of data.
Lack of data. Like, where are you going to get these names from, right? Like, who is going to give you? You can't exactly go to the schools and say, can I have a list of all? They're like, what are you going to do with that list? Like, why should we give you the list of the students in our school, right? And even if you got the list, let's say somehow miraculously you got a list of all the students, what's the next challenge you have now? Somehow somebody gave you a list of all the names of the students. Does that really help you?
You need to know the number per school.
Yeah, so I have a list of 10 million kids who are in school, who are in high school in Nigeria. But remember, I want to collect data from them, right? I have a list of names, but I need to collect data from them. So what needs to happen between the list of names and collecting data from them? Something else will connect the two, right?
Is the sample?
Sorry?
Is it the sample?
No, you have a list of names. You just have one column of names of all the students in Nigeria, of high school students in Nigeria. Sorry? Sorry, I can hear you clearly. How do you contact somebody if you want to do a survey, right? Collect information from them. How do you contact them?
Can contact them like via email, via their mobile contact.
Exactly, right? So even if you got a list of the 10 million kids who are in high school in Nigeria, it's very unlikely that list will have that information, right? immediately their names and their class. So that list still doesn't help you because you still can't contact them, even though you have a list of all the students. Right? So, so sometimes it becomes very hard to create a sampling frame of individuals. And that's the whole idea behind cluster sampling. Cluster sampling acknowledges the fact that in some cases, it is impossible for us to create a sampling frame of all the people in that population. And so we now have to figure out, so we can't get a list of the names and their addresses. What else can we get? So again, like I said, please go and watch the videos we put up. I'm not going to repeat what's in there. So, that will bring it to speed. Then we have the analysis unit. The analysis unit could be different from the sampling unit. My sampling unit could be individuals, right? But when I go to each individual, I then ask them questions. How many visits did you make to a doctor in the last year? Or how many teeth do you have missing, right? And then my research question is titled, the incidence of dental caries. So I go again. Remember, my population is individual. So in each individual, I have, for each individual, each individual is a row, right? But when I go to each individual, I do an oral examination and I count. And for each tooth, I indicate whether the tooth is carious or whether it has missing, it has a hole, or whether is missing, all right? So my analysis ends up being, the percentage of teeth that have caries among this population, right? So the sampling unit for my study was human beings, but the analysis is among teeth. I'm saying the percentage of teeth that have a hole, or the percentage of teeth that have been extracted, right? So in this case, my analysis unit is not the human being. The analysis unit is teeth or number of visits. So you have to understand what is the analysis unit and what's the sampling unit. Sometimes they are the same, sometimes they are not the same. And then we have what we call the parameter. The parameter is some characteristic of a population we wish to understand. Let's say we want to see the percentage of people who smoke. Is there a question? Okay. So let's say our study is trying to understand the percentage of smokers in the population, right? And so we calculate. But please mute yourselves. So we're trying to understand the percentage of adults who smoke in the population, right? We take a national sample, and from that sample, we calculate a number, right? And we say, this is the prevalence estimate, right? Why do we call it estimate?
Yeah, I guess 3 months old.
Sorry?
This.
So why do we call it an estimate?
Because it's a sample of the population.
Okay. Okay, let's give an illustration, right? Let's say you ask a builder to come and renovate your bathroom in your house. The guy comes the first visit and you ask him, so how much is it going to cost? He's like, I don't know yet, right? But you're like, I want to plan. So you ask, what do you tell him then? Give me what? He tells you that he can give you a precise number.
A budget estimate.
You say, okay, can you just give me an estimate? Why is it called an estimate? It's an estimate of what? As opposed to what? We call it an estimate because it's an estimate. It's either an estimate or it's a what?
It's an estimate from the population. No,
forget about the population now. In our example. Like you ask the guy who's renovating your bathroom to give you the cost it's going to take for you to remodel your bathroom. And he says, I have to go to the market. I have to look at prices have changed. I don't know. I don't want to come back and then I will tell you a bigger number and you say, no, but you tell him, no, don't worry. Just give me an estimate, right? So my question to you is this. The number is either an estimate or it's a what?
It's an actual number.
Exactly. right? It's either the actual number or is an estimate. And why do we need an estimate? Because we don't have what?
The actual number.
Exactly. That's why we need estimates, right? Because we don't have the actual number. Now, in science, what do we call the actual number? What's the scientific term for the actual number?
The parameter.
Exactly. See, we have a lot of statisticians here already. We call that a parameter, right? Now, there's only one person who knows what a parameter is in the whole of the universe. Who can guess who that person is? Yusuf, you are really good at this. God, right? Only God knows what a parameter is. We don't know it, right? So the only thing we can get from our study is what?
Estimates.
Estimates. That's the best results that population-based surveys can generate. Can only generate estimates, right? Because we can never know what a true population parameter is. Even if you did a census and you assessed results from every single person in your population, the problem is that there still may be some measurement error, right? Some people may still tell you lies. So even if you're assessing whatever it is, there's always some error, right? So we never, ever can know what the parameter is. And that's why the parameter is indicated with a P, and the estimate is estimated with a P hat in general. And the formula that is used to calculate the estimate is called the estimator. So those are some key terms we need to understand. And then we have a list sample. The list sample is that in which the only sampling unit is the analysis unit. So if we're looking at a sampling frame designed to give us, for example, smoking prevalence, in that case, the sampling unit and the analysis unit are one and the same. So we call that kind of sampling frame a list sample. And then we have bias estimates. So technically, people say, "Oh, that population is biased," right? Is that technically a correct term? Can a population be biased? Yes or no?
No.
So what is bias there?
Bias comes from errors in our sampling.
Okay, so that's correct. So we cannot say the population is biased. Instead, we say what from the population is biased. No, the answer is staring you right here in the face.
Selection process.
Yeah, the selection process is what results in a biased estimate. So the point I'm trying to make.
The sample.
Okay. So try not to say the sample is biased, right? Technically, it's better to say the estimate is biased. The sample itself is just sample. It's the estimate from that sample that is biased. Now I'm getting into the weeds now, but if we're going to talk about technical way of saying things correctly, we might as well go all the way, right? So it's not necessarily the sample that is biased, because the only way you can assess bias is by comparing the estimate with the parameter. Now, we don't know what the parameter is, but we can always estimate it mathematically, right? That is how we assess bias. Like, whoa, we have the estimate and we have a parameter, and they are not the same. So it's not necessarily the sample itself that's biased, it's the estimate from that sample that is biased. So next time you're talking, try not to say a bias sample. Try to say a bias estimate. That's better technically. And then sampling error. Sampling error is essentially error from sampling. And this is something you have to understand clearly. One of the questions in the homework I gave you tested your understanding of sampling error, right? Sampling error is a measure. It is very important. So I'm going to read verbatim what I have here. It's a measure of difference between an estimate and a parameter that can be attributed to taking a sample rather than a complete enumeration. So essentially what we're saying is, let me take a screenshot. Let me draw this. How do I get this? So here's what we're saying regarding the sampling error, right? Let's say that this is our population parameter here, right? And so we took our first sample. We got a prevalence estimate here. Let's call this E1, all right? This gap here between what this estimate is and the population parameter is a measure of the sampling error, right? Ideally, this estimate should have been exactly here. But because of errors in measurements and all of that, that is why we have that gap. And so we took another sample, we got another difference, right? Every single sample we took has some distance away from the true population parameter. So if we spend the rest of our lives taking random samples, and again, take note that this is not one estimate, one individual. We're saying a sample. We took a sample from the population, right? And from that sample, we got an estimate, right? So what we're saying, the distance between that estimate and the parameter, right, gives us a sense of error. And that error is from sampling, right? Is how did we select these people? That's how we got that error. So if we spend all of our lives taking a whole bunch of random samples and we averaged all of the distances, that's what we're referring to as a sampling error, right? So it arises from the fact that there are some errors, sampling and non-sampling errors in how we selected people, right? So some of the questions asked there tested your basic understanding of sampling error. And when we go back to the questions, we'll see how that applies. Let me just highlight some of the key things here. Probability sampling. This was also a question. There was also a question that tested your understanding of what probability sampling is. So, who can define what a random sample is? Based on your understanding, not based on what you see on the slide here. What's a random sample? So just pretend you haven't seen this line here. So what do you understand by when you say a random sample? What does it mean? So complete the sentence. Is a sample in which blank? Where are my go-to people? Where is Yusuf? Where are you? You are quiet now. The sampling has no order. Okay. Where are my other go-to people? Shade and Ishayan, where are you?
Okay, let me say something.
Okay, go ahead.
Yeah, is this sample at which every individual has equal probability of being selected?
Thank you very much for supplying the wrong answer I was looking for. So can you repeat? Can you say it exactly the way you said it? Have you run away? Please don't run away.
No, I'm here, sir.
Okay, great. So can you repeat? Can you just say exactly what you said?
Okay, I said is the sample in which every individual has equal probability of being selected.
Do you know the major problem with that definition of yours? The key word that makes it problematic for us.
Okay, equal.
Equal. That is the problem. Now let's go back to my own definition, right? What do you see a difference between your definition and my definition? And that's to anyone, right? What's the difference between the previous definition and the definition I have provided here?
Cannot be determined.
Is the word equal there?
So which are you referring to? The random variable?
No, the probability sample.
Oh, every unit has a known non-zero selection probability.
Yeah. Why I? So what's the difference between your definition and my definition?
You are referring to equal probability sample.
Yeah, so probability sampling in general, does it require that everybody have an equal probability of selection? That's a key question now, right? We're asking.
No.
Is that a requirement for something to be a random selection, that everybody has an equal selection probability?
No.
No. You can have
No, I think it's
selection
just equal chance.
No, chance and probability, that's potatoes, you know. The key word we're trying to say is the issue of equality. Not everybody, they don't all have to have equal chances of selection for it to be a random sample. In some random selection, we have unequal selection probabilities, right? So what we're looking for is not that, it's not equality. What we're looking for is that everybody should have a non and non-zero selection probability.
Okay.
Does that make sense?
Yes.
Okay, let's explain what these words mean. This sounds like jargon. Sorry?
No.
Okay. So let's explain what those terms mean. Let me clean this up. So the key words there, and so we need to go through this so that when we do the homework, you understand how everything falls into place. Otherwise, it won't be so beneficial. So in case you're wondering why we're spending time on this, well, you need to understand the theory. So we said the word we did not want was equal. This was the word we didn't like. And we said the words we wanted instead were
non-zero.
None. And it's so hard to write with this stuff with your mouse. My handwriting in real life is better than this, please. So we like this one. We don't like this one. Okay, so non and non-zero. A probability is made up of two numbers, right? Probability is made up of two numbers, a number at the top and a number at the bottom. So if we have 7 guys here, or let's say, and the green ones were selected, the probability of selection in this case is equal to number at the top is what? So the green ones were the ones selected.
4.
So what's number at the top?
4.
The sample.
For green.
And what's the number at the bottom?
8.
8.
So the probability of selection here is 0.5, right? So you can only calculate probability when you have both the number at the top and the number at the bottom. Do we agree on that?
Yes.
So we say the probability is only known if the number at the top and the number at the bottom is known to us. If we have only the number at the top and number at the bottom is not known to us, or we don't know it, then we cannot calculate probability, right? And so when we say a sampling is non-probability, it means that we cannot calculate it. We are unable to calculate the probability. That's why we call it a non-probability sampling, because it is virtually impossible for us to come up with a probability. Now, if you put your survey here, right? Let's say you do a survey and you post the link on WhatsApp or on LinkedIn or YouTube or wherever, or Facebook, and these are the people that came and did your survey. You know that, oh, 1, 2, 3, 4, 5. You know that, let me remove 1, so that's still 4. So you posted your link on Facebook, right? And when you look at your data set, 4 people participated in the survey, right? What's the number at the top in that case?
4.
What's the number at the bottom?
4.
0. Unknown. 4. Unknown.
What's the number at the bottom?
4.
No, 4 people are the people who participated in your survey.
Okay.
Out of how
It's
many people?
unknown. It's unknown.
Undefined.
Unknown.
Exactly. So are you able to calculate the probability here?
No, sir.
No.
No. So we say that what kind of sampling is this? This is what we say. Since it's not known, we call this, since you cannot calculate the probability, we just put none in front. We can't calculate the probability in this case. That's why we call it a non-probability sample. None, because we are virtually unable to calculate the probability. Right? So here, can you say the probability of this is none?
No.
No,
No.
you can't, you know. So that's the meaning of that word here. When we say that the probabilities have to be first thing first, it has to be none, right? That's what we mean by that word. And then the other second word here is that probability has to be non-zero. Let's explain what that means. So that means everybody in your population, let's say we're doing a survey, right? Let me move this here. Again, these are basics of probability that you're like, we expect every single researcher to know, right? With no exceptions. So you're doing a survey of, let's say, this is Nigeria, right? Let's say this is called survey of Nigeria. And then in the northern part of Nigeria here, there are people living here. Let's call this the Great Sambisa Forest. And there are people living there, right?
We don't know.
So now you are naturally afraid to go into that forest, man. Who can blame you? So you survey people here. So 1, 2, 3, 4, 5. Okay. Let me remove this. All right. So here, this scenario is a bit different from this one here, right?
Can you bring something for me?
All right. So here, what's the number at the top? What's the numerator? So remember, there are people here, right? So you went all across. This is the places you visited for your survey. All these places highlighted in green, right? These are the places you visited and accessed. So within here, you did a random sample. So what's the number at the top here?
4. 4.
What's the number at the bottom?
8.
8.
Okay.
Unknown. Okay.
So let's go with 8. Now, well, what's the problem here now?
Some people are left out.
Why can't we say 4/12?
You can say that if only you know the people that were in the Sambisa.
Is it knowing them that matters, or giving them a chance to participate? You remember, this is where you went to. Does anybody in Sambisa have a chance to participate in your survey?
No.
No, they don't. Because you were afraid to go there. Remember that when you went here, you drew a lucky draw and you say, okay, the 4 lucky people are the ones who were selected. These guys never stood a chance to participate in your survey, right? So that is why the denominator here is 4/8, right? So here you say that your survey, the chance of being selected is 0.5, right? But we have a problem, right? These guys were not captured. So if you're as a scientist, right, if you have this problem in the field, what do you do? What's the easiest thing to do to solve this problem?
You wait.
Sorry?
Waiting.
You wait till when?
Oh, can I say the limitation of the study? Reason why they are cut off.
Why say limitations when you have a better solution? So I want to think on your feet now. You are the survey statistician that was brought to Nigeria. You've been paid millions of dollars to conduct the study. You can't be giving them limitations, right? So what's the easiest solution to this problem?
Use non-probability sample.
No. The hint here is that the solution is just grammar.
Purposive sample.
No. Purposive sampling is non-probability. It's non-probability. I already gave you a hint. I said the solution is grammar.
Cluster?
No, grammar, English language.
Phone calls.
Oh, no. Where are my people? Let me see.
Non-response.
Okay. Where's Yusuf? Yusuf, why
You
you not
can take a
responding?
sample from the total population.
Okay, let's look at language, right? Let me show you some language, and you can see. So let's look at MMWR smoke chain. Let's analyze some language, and hopefully that would give you some ideas of the answer I'm expecting from you. Can you see the screen?
Yes, sir.
Yeah.
Okay, somebody should read it out for me, please.
Is it only the highlighted ones?
Just the highlighted part, yes. So, okay, I'll read it. Okay, please go ahead, yes.
An annual national representative household survey of the non-institutionalized U.S. civilian population.
This part here is packed full of meaning, like you will not believe, right? They say it's nationally representative, but we also put this big clause there, the non-institutionalized U.S. civilian population. What does that even mean? Who is not included in? So first of all, did we include everybody in the U.S.?
No.
Did we include? So we said, okay, we cannot reach the military, right? Why can't we reach? Why do you think we cannot? Because we say civilian. Why do you think we cannot reach the military?
Because they are based in the Sambisa mostly.
They are in Sambisa. They're deployed everywhere around the world, right? The US has military bases everywhere, right? So we cannot reach the military. If we claimed that our survey was a national representative, so if we stopped our sentence here, if we stop our sentence there, NIH is an annual national representative household survey of the US population. Oh, we're in trouble, right? Scientifically.
Yes.
Someone will say, oh, but what of the military? The military are everywhere. Did you sample them? Right? And you only went to household. What are people who are in prison? Right? What are people who are in nursing homes? Did you sample them? What are people who are in some other geriatric centers, right? What are people who are on the streets, right? Oh, so you did not reach all those people and you are claiming that your survey is nationally representative. So we have simply solved that problem with grammar. See? By saying this, we have solved all of that problem. We now say, oh, our survey is a national representative survey of everybody except the people that we could not reach, right? Those who are in prison, we are excluding them. Those who are in jail, who are, in nursing homes, those who are in the military, we cannot reach, we cannot access them. So now let's go back to Sambisa, right? You are the chief epidemiologist or the chief scientist. How do you solve this problem with just simple grammar? You reached everybody here. These are the guys whom you just couldn't reach. So how do you, it's a very simple solution, really. It's not a trick question. I promise you. Nobody? Yeah, so can you put it in a sentence? So this survey was like, I want you to frame it the way we saw it in that MMWR.
Yeah, I think. Hello?
Yeah, go ahead. We can hear you.
Yeah, I think this can be factored out without inclusion of the dose and Sambisa. So
Can
this
you give us
can
a
be
sentence? Can you frame a sentence, please? This survey was, continue the sentence.
This survey was conducted with exclusion of those in Sambisa forest.
Okay, or we can also say this was a representative survey of the Nigerian adult population outside of the Sambisa forest, right? There are a million and one ways we can frame that, but by saying that, we have automatically solved that problem. So now we can say that everybody has a non and non-zero chance of selection. For those who are in Sambisa, what's their chance of selection?
0.
0. So that takes us back to our slide, right? Where we say that everyone in a probability sample must have a non and non-zero selection probability. Does that make sense now?
Yes, sir.
Yeah.
All right, great. So, so the point I want to really emphasize is that in a random sample, you have some sampling techniques that will give you a non-equal selection, but it's not equal, but it's non, and it's non-zero, but it's not necessarily equal for everybody. That's what we're going to cover next week. This week, we are covering equal probability samples where everybody has a non-zero and equal chance of selection. All right. So you use simple random sample when you have a frame that is complete, correct, and current, right? That's when you use a simple random sample. And then, in all the instances, you use a cluster sample. So let me just quickly go through a simple random sample, and then we'll do our exercise. Simple, it's called simple because it's just the simplest. We don't use it in large surveys because, well, it requires that we have a list of everybody. Again, you have to go and watch the videos, the 2 videos we posted. Please, can you mute yourself? For you to really understand the basics or the mechanics of simple random sample. So we don't use it in large surveys because we don't always have a sampling frame. And it's not efficient at all. So imagine we're doing a national survey in Nigeria. We needed 100 people, right? And we do a random sample of this 100 people. We might have to fly all the way to Zamfara and just to survey one person. And we go there, we stay in a hotel, and we just talk to one person who may not even be around, And then so it's inefficient. Trying to get a simple random sample is a very inefficient process in terms of money and time. I mean, it's great statistically, but in the real world, we don't use it that much, except when we have a very well-defined area where we have a list. There are 2 types of SRS, simple random sample, sampling with replacement and without replacement. I won't go into the details of that. That's beyond the scope of the talk. I won't also go into how to do it manually because we're going to use the Chisquares platform to do it automatically. So there's no point telling you, oh, you do this. You don't have to know all of that. We're going to cover it automatically. So this is a very important slide, but I'm going to give you that this will be the basis for your test for next week. So hopefully you guys can earn my $100, but my test for next week will test how the y-hat is an unbiased estimator of the parameter when you use a simple random sample, and how the variance calculated from a simple random sample It's different from that from a cluster sample. That sounds like grammar, but next week you understand what that means exactly. I need to be as clear as daylight to you. All right, so let's talk about systematic sample, because that's one of the issues in your homework. So systematic sample is based on an ordered list. It is the only sampling technique in the world that is influenced by how you sort or what you sort on. So in the sampling frame I gave you several variables. One of the things was I was testing your judgment. If you're doing a systematic sampling, which variable do you choose to sort on, right? The variable you're selecting must be highly correlated with the outcome of interest, right? We're going to see more of that when we do the hands-on practice. But that's the end of our lecture. We'll now go to the and see how we implement those two types of sampling and answer the other questions. Any questions or concerns so far? Questions, concerns, issues? No? All right, great. Now let me head over and so this is the sampling frame you have. These are the questions. So let's look at the questions. Okay. Okay. So this, first of all, I showed you a small table and okay, the editor-in-chief. Somebody said the keyword here is convenience sample. Point prevalence estimates and 95% confidence intervals were calculated among a convenience sample. So convenience sample, is it probability based or non-probability based?
Non-probability based.
Non-probability.
Exactly. So the question then is, what in the world how are you calculating confidence intervals for a sampling that is not the non-probability, that is not at random, right? Remember that the confidence intervals is simply a measure of if we spend the rest of our lives taking samples, right? How sure are we that the estimate falls within the population parameter, right? You can only have confidence intervals when your sampling is at random. There is no mathematical basis to calculate confidence intervals when sampling is done not at random. So you are the editor-in-chief and somebody told you that, oh, this was based on the confidence sample, and you still see them calculating confidence interval. You don't even need to read the paper. It's like you should say, what? How? I am confused. Did we just reinvent math or did we just reinvent statistics, right? How are you calculating confidence intervals? Like, I need to know, like, is there some special procedure you're doing? Like, because there is no mathematical basis. But remember the concept of sampling error? Sampling error arises because we are selecting at random. No sampling error. So no random selection, no sampling error, no confidence intervals. So if there are no confidence intervals, why are you showing me confidence intervals? Of course, the computer will generate things for you if you ask it, right? But you are the expert who is supposed to know, okay, this doesn't make sense. So the computer gave us this, but we're going to remove this part, and we're also going to show only this part here. So, oops, let me keep this table, copy. And so this is what you are to tell the user, that the researcher, that there's no mathematical basis for calculating confidence intervals when your sample was a non-probability sample. So please delete the confidence intervals and present just the estimates. Does that make sense? So that is what is wrong with this table here, because this person has reinvented math, and we won't allow that. Are we on the same page on that? Any questions? All right, great. Question number 2, a researcher is using systematic sampling to select participants from a survey. Now, this is an excerpt from her paper. She says that data were collected probabilistically. We have a problem with this word. Now, systematic sampling, is it random or non-random? Let's go back to the slide.
Random.
So systematic sampling, where does it fall? Is it probabilistic or non-probabilistic?
Non-probabilistic.
Probability.
Probabilistic.
Okay, now perhaps I should put a big fat asterisk here. That big fat asterisk could say that it is probabilistic under certain conditions. So essentially, this is what, let's visualize what systematic sampling is. Oops, how do I draw this? Okay, I think I'm out of scope. Let me delete this. All right, so that's enough. So this is, so we say we first of all order the list, we sort it, and then we calculate the sample interval. So let's say our list has, let's say our list has 1 to 500 names, right? And we want to select, let's say 30 people from that list. Our sampling interval, therefore, is 500. Let me use 50, so it's easy to calculate. Our sample interval is therefore 500 divided by 50, which is 10, right? So that means that we're going to start. So we have 10. This is the 0%, 1 first person to 10. We're going to start somewhere here, and then we're going to jump every 10 people. Every 10 people, we're going to jump until we select all the 100 people we need in our survey, all the 50 people we need in our survey. That's what systematic sampling is. It's just a bunch of jumps, or jumping. So we start by listing a number between 0 and 10, which is a sampling interval, and we jump every single 10. Now, I should tell you that systematic sampling is what determines whether systematic sampling is random or not random is how we started. Like, how did you select the first number? So who can give me the rule? Who can now guess the rule for when we say systematic sampling is random and when we say it's not random? If we selected the start point, how, then we say, so fill in the sentence, fill in the blank. If we selected the first number blank, then it's at random. If we did not select it blank, then it's not at random. So who can fill in the blanks?
I think randomly. If we selected the first randomly, then it's random. If it's not, then it's not random.
Excellent. So what's the problem we have here with this lady?
It was a convenient, the first selection was a convenient sample.
No.
Random.
So the proper thing says that first selection was it at random or was it not at random?
Not at random.
See, I even gave you a hint with the smiley face here. What more could I give you?
It's what at random first.
So the problem is that her first selection was not at random. That completely makes the whole sampling what?
Non-probabilistic.
Exactly. So the problem is that she now says data were selected probabilistically. No, man, that was not correct. Data was selected non-probabilistic. Why? Because your random start was your first start was not random. It was your favorite number. And so that makes it completely non-random. I hope that's clear. Does anyone have any question on that? No, yes, we're good.
We're good.
All right, great. So you see why I was surprised that nobody got my $100.
I got it. Okay, I got it. I got it.
Oh, you got it?
Yes, I did.
Okay, that's great. Question number 3. So this person used data from DHS, demographic and health surveys, right? We've provided some context for that. So the question is, you have 3 statements. You are supposed to agree or disagree with those statements. Does it make sense or does it not make sense? If it makes sense, why? If it doesn't make sense, why? So, and this one we've already explained. We use data from the South African demographic and health surveys where participants are selected at random. Probability-based surveys where people are selected at random ensure that everyone has an equal probability of selection. What's wrong with that sentence? With that statement, with that paragraph?
The equal probability.
Exactly. You should know that by now. So no, that is completely incorrect. And I tend to see a lot of posts on LinkedIn where, for whatever reason, probability seems to be very popular on LinkedIn nowadays. I see a lot of things about probability, and 95% of them are completely incorrect. So I'm okay. That's interesting. Now, in her results section, she says that weighted analysis showed that the prevalence of smoking in the overall population was 20%. What's wrong with that statement? And then 900 over 4,500. What's wrong with that statement?
I think the weighted analysis, because it was a standardized population also.
No, but then remember the text here says that that using weighted analysis, that yes, indeed she weighted the data, so that's fine. The surveys could be standardized, but also weighted. Standardized simply means that we use the same methodology in all the countries. So if we go to each country, if in country A we go to 15 years old and we do it a certain way, we do that way for all countries. That's what standardized means. But you can have surveys that are standardized and also weighted, so they're not exclusive. They're not mutually exclusive of each other. So what exactly am I looking for in that sentence that is wrong? Okay, let me tell you. When we do weighted analysis, we don't display these numbers, right? In fact, one rookie error is to people when people publish estimates, and somebody will go and some smarty pants will go and say, "Oh, I took the raw data and I counted the number of people who are smokers, and I divided by the total number of people in the data set, and the answer you gave is wrong." It's like, okay. When I was at CDC, we used to have that quite a lot. People would publish an MMWR, and people would just get a lot of feedback that, oh, the number is wrong. I calculated the gain and I counted. It's like, okay, have you heard of something called weight? So what I'm trying to say is that in weighted data, this is very likely not going to give the same answer as this. So when we present results from weighted analysis, we don't present this over this, right? So let me show you an example. Let's look at two MMWRs. MMWR smoking. So if you see, we present just estimates, right? Just estimates. We don't present this over that, because that doesn't make any sense, Now let's look at another MMWR that has well, let's look for, let's say, let me look at the paper and just jam it quickly. To show you how it is different when we look at weighted analysis versus unweighted analysis. No, that's not what I'm looking for. Primary research. If I can, oh, this is a research latest. Let's look at this. That looks like primary research. Let me expand this. So maybe too much. So let's just focus on abstract quickly. That's what the results. Mean, I'm looking for percentages. So you see, overall, 300 participants, they provided the end at the beginning, right? But 600, overall 300 participants, 89.5, receiving this medication, maintain whatever. See how we report that? So in unweighted analysis, let me come back to the main section here so we can see that better. So you see, consistently, you report the N and the percentage, right? You report the percentage and the raw number, the raw count. You only do that with unweighted analysis, right? So this was weighted analysis is where we use weight. Okay, we had a session on, we had a bootcamp on weight, but we're gonna have another one. So please just make sure you follow up. Because we cannot talk about random sampling without weight. So again, we'll have a bootcamp on that. So just make sure you follow. Anyway, this is incorrect. And again, for you to know why it's incorrect, let's just follow up in the next class we have. So that's what's wrong with that. And then this one. Who can guess what's wrong with this sentence? But I expected those of you who have been following us and have been attending our courses, I expected you to absolutely get this correctly. Those of you who have not attended our boot camps in the past, well, you are forgiven. All right, what's wrong with this sentence here? Okay, let's compare this analysis back to, let's go back to the MMWR and pay close attention to how we report things there. Let's go back to that same MMWR here. So this data was, remember that this analysis was based on, in 2021, a total of 29,482 adults were surveyed, right? So let's just focus on this part. In 2021, a total of 29,482 adults were surveyed. Data were weighted to provide nationally representative estimates, right? Keep that in mind. Now, look at how results are framed. Among US adults in 21, they didn't say among the participants, they didn't say among the 21,000 people who were surveyed. They say among US adults in the nation, right? Why? Because once you weight data, you are shifting focus from, let's go back to our slides. When you weight data, this is the magic that happens. You are completely shifting focus from the sample to the bigger population. So sure, we analyzed data from 29,000. The magic of weighting is that once we weight the data, the inferences have shifted entirely. We have completely ignored the sample now. So we're not interested in saying 20% of the sample smoked. No, we're saying 20% of the population smoked. So that's why we say 20% of US adults smoked, not 20% of the participants we sampled. So in this, the problem here is that this individual did weighted analysis, but they're still talking as if the data were not weighted. They're still saying, they say the result from weighted analysis showed that 1 in 5 of the analyzed population in the data set. It's like, okay, that does not make any sense. I hope you understand what we're saying. And again, those of you who have never attended any of our boot camps on weight or weighted analysis, you're forgiven for not understanding, but you should make sure you follow us and know for the next time. So the last one is the simplest, is the sampling. So let's go ahead and, how many of you were able to do the sampling? Let me see your hands up. Were you able to sample? Oh, nobody was able to sample. Okay. All right, let's see how to do that then.
Yes, I did.
Oh, great. That's great. So let's head over to Chisquares platform and let's log in. And we'll go to sampling, yes. Start new sample. This time around, we're sampling on our own sampling frame. So we're not going to select automatically draw representative sample. We'll use the second option, which is perform probability sampling on the sampling frame. We'll upload the data where the sampling frame is from, which is what I have here. Okay, that has been uploaded. Then we select a sampling approach. The question said, draw a simple random sample of 200 individuals from a data set and estimate the mean of metabolite X. So the sampling approach is simple random sampling. The next field is there an identifier? Well, it's optional, but we have a unique ID, but we don't have to use that. So I'm going to leave it. And then the desired sample size is 200. You can only select up to the maximum. There are 516 sampling units in our sampling frame. See, I'm using those terms, right? Because I'm trying to make sure you understand them. Or, you remember them. So our sampling frame, which is our Excel spreadsheet. So from now on, henceforth, we're not going to use those colloquial terms like our spreadsheet. We'll say our sampling frame has 516 sampling units, right? And our goal is to draw, again, the word is draw. Draw a representative sample of 200 individuals using simple random sample. Now, the platform implements, I'm sampling without replacement. So that means that if I say I want to sample 540, it's going to tell me that no, there are a total of 516 people. So you can only sample up to that number, right? If we sampled 516 out of 516, is that sampling or is that a census?
Census.
That's a census, exactly. So we're selecting 200 people, and then we click on Get Sample. So that was all that was required of it for that task. And then, of course, this is the output. You have this tells you the probability of SRS. So you can see everybody has an equal probability of selection. You see that here? So SRS is one of the sampling techniques where everyone has an equal probability of selection. So you see everybody 0.3876, 0.3876, everybody. That is the probability of selection. So the question was, use the Chisquares platform to draw a simple random sample of 200 individuals from data sets and estimate the mean of metabolite X from the randomly drawn population. So this is a randomly drawn population. So let's download the data, the results. So you click on download. It has downloaded it. Let's pull it up into our Excel spreadsheet. Let's pull it up and then calculate the average. So let's open it. Downloads. So this is what we had here. So the question is, we should calculate the mean of metabolite X. So this is I'll just use the basic Excel, the average of this. And so the mean of metabolite X is 53.43. So that's all this question is asking you to do. Where's the question again? So use the Chisquares platform to draw a similar sample of 200 individuals. We did that. Estimate the mean of metabolite X. We've done that from a randomly drawn population. Show a screenshot of your selections on the platform. So of course, I wanted to know what you selected. So I expected you to show me screenshots of this so I can see, okay, you selected the right element. So that's all you have to do for that question. The next question is, use the Chisquares platform to draw a systematic sample of 200 individuals from the data set and estimate the mean of metabolite X from the random draw population. Again, this time we're just changing from simple random sample to systematic sampling. Now, systematic sampling, remember, we said one thing is special about it. It is the only sampling that is blank. Who remembers what we said about it? There's some very, very special thing about systematic sampling. It's the only sampling. Sorry?
Sorted.
It's sorted, yes, and as a consequence, it's influenced by how many variables can you sort on?
1.
1. So that means that the choice of sorting variable does what? Influences the outcome, right? The variable which choose to sort on influences the outcome. So here we're asked to select sorting variable. Now, what variable should we choose here? We have shoe size, right? Metabolite X is our outcome, right? Metabolite X is, and remember they said metabolite X is, what is metabolite X? Metabolite X is a biomarker related to vibranium fever. So it provides insights into metabolic changes that are associated with the disease or its treatment. This is what our outcome is, right? And we have, these are the variables we have here. The unique ID, we have name, phone number, zip code, the length of hospitalization. Remember, all of them are hospitalized. Now, we said that when you are choosing a variable to sort on, you must choose a variable that is highly correlated with the outcome. So let's think about it, right? Is your shoe size likely going to be correlated with your metabolite X levels? What do you think?
No.
No. What about zip code?
Yes.
Okay, perhaps.
No. Yes.
You can argue either way, right? Maybe you come from a poor area, and so, of course, zip code is an indicator of where you are. Yeah, so it's possible, right? It's possible. It's possible that it's related, it's possible it's not related. And then you have your phone number. Is your phone number likely to be related to your levels of metabolite X?
No.
No. What of your name or unique ID?
No.
What of length of hospitalization?
Yes.
Yeah.
So again, the point in that systematic sampling is the only sampling that is influenced by the order of sorting or by the variable you sort on. When choosing a variable, so this was a trick question. I wanted you to test your understanding of that principle. And that's why I also asked you for your screenshot. I wanted to see which variable you had selected to sort on, right? So definitely I'll go with length of hospitalization as a possible variable to sort on. I select the number of people that I wish to, and then it sorts it on. So you see how it's sorted on length of hospitalization, 8, 12, you see, and then these are the ones that have been selected. So the beauty of systematic sampling is that since it sorts it on
the person never come.
Are you speaking with us, or is that just some noise? Please, can you mute yourself if you're not speaking? Not speaking to us, at least. The beauty of sorting is that it allows you to get a flavor of everything across the range. So remember that you are jumping at intervals from the smallest to the largest. So it gives you that flavor across the whole thing. Now let's download this too, and let us see how the results compare, because that was the third question you had. So remember that for this one we had 53.48. So let's upload the results we got from systematic sampling. I think this is it here. So again, this is just average of metabolite X levels. So we have 50 points. Do you expect the estimate to be exactly the same? Yes or no?
No.
No, of course, that's a very unreasonable expectation, right? Which is, well, when I was a citizen, that was one of the things we had to always explain to lawmakers. First of all, they were always wondering, why do you have so many surveys you're conducting across the country? And then why are they not giving us the same number? In this survey, you said prevalence of smoking was 21. Here you're telling us it's 19. Which one are we supposed to believe? Let's explain that. Look, there's something called sampling error. That's why we have confidence in intervals. Trust me, they never understood that concept. So you don't expect the estimate to be the same. That's why they're called estimates. And what are they estimating? The estimate of what?
Do you mean?
Sorry?
Parameter.
Exactly. Estimate of a parameter. We don't know the parameter, right? So if somebody tells you which one is correct, like I don't know. they're all estimates. Only God knows what the parameter is. So that was the question you were supposed to answer, right? And then the third question was how do selection probabilities compare? So again, in systematic sampling, everybody has an equal selection probability, as you can see here. The probability of selection for everybody in the systematic sampling is equal. So it is one of those probabilities that also it's one of those sampling techniques that also give you an equal selection probability. So the sampling techniques we've looked at today are just the basic, the simplest sampling techniques you could ever do in the world. Simple random sampling and systematic, and those are equal selection techniques. Everybody has an equal selection probability, as you can see on the screen. All right, that's the end of our class. I don't know if you have any questions. We've answered all the questions. So you can now, your goal is to go and answer it again yourself and submit your answers. Everybody should be able to get this right now. So you can see why I was disappointed nobody claimed my money. Because I really thought you guys were going to finish it in 5 minutes or something. But well, it's what it is what it is. Any questions? The link is not loading.
Yes, sir. Please, is universal sampling, is it a probabilistic sampling method or non-probabilistic?
What do you mean by universal sampling? What does that mean?
I saw it in a paper. They said that universal sampling involves collecting data from everybody that is available in a particular setting that one has intention of studying.
Well, so, and everybody, then that's one guy sampling, right?
Yes. Okay. But they said, so what is it if it's not a sampling?
If it's not a sample, it's a what?
I said, I'm asking if it's not a sampling, what is it? And because they said it's a method. Sir?
So I'm asking you, if it's something is not a sample, then what it is? What is it?
It's a census.
Exactly. So yeah, so it's either you draw a sample or you get a census, you know. And so, but again, census does not mean that it's everybody in the country. That's why you have to define your population first.
Okay.
And so you're like, okay, in this population, we did a census of everybody. So you have to understand. That's why you have to really understand. Don't get carried away